Welcome to the best presentation I'm going to give during this GeeCON. It's better than the opening, I promise. So our talk is called Unveiling the Tech Underpinning FinTech's Revolution, or basically how to do software well and quick.
At scale.
And scale, and techniques for simplified large-scale systems. Preempting, it's mostly about how and people and organizing that. I don't think we have code in there.
No, but that's probably the next presentation we're working on, by the way.
So the first question, and a very important question that you should keep always asking, is why? Why is it that some organizations do magic, do incredible stuff, they keep delivering, they keep pushing things out, and some can't. Some are just stuck. What is it? What's the reason?
Hands up if you ask yourself the question, what makes one company more productive than others? Okay, that's good. That's good. The rest, where are you working? Is it the best company in the world? Okay, you can do that. That's fine. But we asked that question, by the way.
And we've also researched what other smart people have found around that question. What are the answers that are common across the industry? And there is a particular trend of thought originating in the same group of people that came up with the concept of DevOps, and so on and so on. The answer, as they say, lies beneath the surface, and they call it culture.
Engineering culture, an interesting word. Okay. So to speak about the engineering culture, we really wanted to use the very similar model that you are, I guess, touched by, but you may not recall if you haven't really dug into the DevOps world and what's behind the DevOps really. So behind DevOps, there is a very interesting research made by Dr. Westrum. And it's called Westrum Organization. So this person really spent the whole life researching what are the organization and how high-performing organizations are different from the others. And that really impacts the way we work as engineers, as software engineers. And we're going to have 3 sessions of pain during this presentation, and you can measure the level of pain, and you can answer yourself, do I want to contact one of these companies in the hall because my level of pain is too high? The first is now. Okay, so Westrum said there are 3 types of organizations. The first one is pathological, power-oriented. I think we know what's coming, right? Among the different things, there is low cooperation, really discourage collaboration. You really shoot messengers on site. So if I come and say, it's not working, everyone says, shh, our KPIs, right? Our bonuses, etc., etc.
Or if somebody complains too much, they will be exited swiftly because, hey, they notice things which nobody talks about.
Because we're the best organization in the world, right? So that's the pathological organization. I would ask you hands up if you work in such an organization, but maybe let's skip this session of pain.
Another type of organization, which is less bad, is bureaucratic. A place in which rules are sacred, rule-oriented, very formal. Cooperation exists, but it's obviously following well-defined paths. Messengers are neglected. Well, they are necessary evil. There are some paths to make it very uncomfortable for them to follow. Responsibilities will be well-defined, bureaucratized, but very narrow, so that, hey, no, if that's outside of my silo, I will not venture there.
Plus, there is a process. So whatever you do, there is a process, ticket, blah, blah, blah. You know it, right?
And process is king, and queen, and the emperor, and everything else. Lisa Nile process.
Yeah, exactly.
Novelty is a source of problems, which means let's maintain the status quo and change nothing. The world will obviously follow us, not the other way. And the response to failure.
There is a third type of organizations, which we want to focus on today. So,
the best
third one. Sorry.
The best one is called generative, performance-oriented. If you need a quick way of understanding what is it, startup in the most chaotic creative phase. Things happen, cooperation is high, everybody works with everybody. Messengers are trained because people want to have the signals and people want to cross-collaborate, cross-pollinate ideas. All of the fancy terms that you hear about in the marketing slides, sometimes they actually happen in organizations.
So I hope that was the first session of pain. I hope that you could measure a little bit of pain and understand which type of organization do you work with. Second question you need to ask, which type of organization do I want to work with, right?
And one thing about data generative type is responsibilities are shared and collaboration is encouraged, which means the attitude that you can distill it down to it's, hey, it's my problem or it's the company's problem, I'm part of the company, I'm going to fix it or I'm going to try to make somebody fix it or help them notice and let's fix it together. It's an awesome place to work in and it's fun, at least for us.
And why do we want to talk about that? Right?
Okay, before we get there, my name is Andrzej Grzesik. I know I'm in a country that actually can say my name and spell it. I build distributed systems at a place called LMAX. If you know it, you know it. If you don't, it's an exchange. I have a Twitter, an email. I identify with some icons. And LMAX, it's a low latency exchange. So people trade. And it's written in Java. And it's very fast, so hundreds of thousands of transactions, calculations per second, which means 85 micros is safe to be sustained. Are your systems that fast? That's not up to me. Do they need to be that fast? Well, this one has to, so it is. And again, pure Java. No magic, no esoteric things, just computer science and proper things.
And I'm Wojtek. You can know me from a number of things, I guess. I love building products with teams. So currently working with Revolut. And I'm responsible for Revolut business engineering. So if anything doesn't work for you, I'm the guy to throw the tomato at. I'm also, you can know me from CTO Morning Coffee. And I tried not to kill myself for various, different ways of spending time. And about Revolut, why is it important to give you a background? You probably know Revolut from traveling, but it's really a hyper-growth scaling company. So the stuff that I'm going to discuss today, I can see it with my own eyes. And to give you the perspective, it's at the moment, it's 40 million retail customers. When I joined, it was 1/3 of it, and it was 2 years ago. We see over 66% and growing user-based growth, so you can see where it's going. And at the same time, we really have a rapid product development. I'm going to talk about that a little bit. Plus, we wanted to stress out the opinions are ours.
For some context, I also worked at Revolut. I was head of backend. When I joined, it was roughly 120 backend engineers. When I left, 3 years after, it was 400. This growth is really intense. But there are things that we've learned, but we're not going to only share things that we've learned from one place. We're going to share things across our history. So, Westrum.
Coming back to Westrum. So we told you that there are different types of organizations. And the first thing that you can take from this presentation and come back to work with is how to measure it. 1, 2, 3. OK, I think my mic is not working ideally. OK, so how to measure it? The answer is ask. And if you're interested in measuring your culture, now pick up your phone, because this slide will be interesting for you. So my recommendation is do the survey from I strongly disagree to strongly agree. Ask different teams, ask your team, ask different teams around the company, and you will see exactly how people perceive the culture. So here is the article. It's on, as you can see, on the main DevOps website. If you're interested in more details, I definitely encourage you to look up this podcast with Gene Kim. So you should know him if you're interested in DevOps. He's interviewing Dr. Ron Westrum, so the creator of the Westrum model, and he's discussing a number of things, very interesting research about different organizations, including what is very interesting, the organizations that train pilots not to make any mistakes. And similarities between training pilots not to make any mistakes and us, engineers, making systems that can have 100% uptime is staggering, I would say. So it's, I truly recommend it. Okay.
Surprise, surprise, the common thread is people. So, Conway's law. You add people, you add problems, the organization is going to follow certain patterns. You probably have seen this picture. What's in this picture? Well, somebody could say microservices. That wouldn't be bad, but it's also the communication structure in the organization, maybe how services interact, maybe how knowledge is distributed, maybe the departments and the interactions. Those pictures will usually resemble each other. What is not in the picture is the problem that we wanted to talk about, or what's hidden, and we know what's that. And that problem that we wanted to call out is problem of knowledge discovery. That's a name I call it by. Maybe there is a different formal one. And that's a problem of, in an organization, how do you know what you know? Who knows what? Is there a piece of code that solves a problem I'm trying to solve? Can I find it? Is there a library? Is there a service?
Is there a service?
Is there a team that does it? What is the correct department if I need to print an invoice, which has some specific cases? If I want to enter a market with specific requirements, is there a team that I should interact with? And so on and so on. Who knows? Who's the best person to reach out? What do we know? What skills do we have in-house? What do we outsource? Do we already have an outsourcing partner for something, or do we already pay somebody for that?
To sum up, the problem is, how do we know what do we know? So the first recommendation of the tooling, if you really want to scale the organization and be productive at the same time, not to get mad at trying to understand everything, is from our experience, ensure service discoverability, right? So I should be able to go and check, because every larger company will have hundreds or not, if not thousands of services. I should be able to get to know very quickly all of the details.
So one of the examples of that tool that solves it is something that's called Spotify Backstage. If you know it, you know it. If you don't know it, it's basically a tool in which you have information about teams, products, services they allow. There's a bunch of plugins, so you can plug in databases, interactions, other things. The point is, if you know, you know. If you don't know, you have a single place in which you can look things up, which means you can discover it on your own, which means self-service is satisfied, which means I can do my work and I don't need to wait for other people. And in a small place, everybody knows just by magic, by working together. But if you are in a distributed environment and the organization grows and it becomes more complex, it's harder. And discovering that, telling new people who join the organization, or if you have a new service, well, that becomes a central pillar at which you look to figure out, okay, what's happening, what are the things that we have.
The beauty of such tools is that you can extend them. And the thing that we truly recommend for these systems to have included is, for instance, description of every system, right? So I should be able to really understand in plain words what each system does, what is a responsibility of it, what is the materiality of it, right? So how important it is to the company. Why? Because if I'm going to be dependent on the service, it's important if, for instance, the other team treats it as low materiality, so it can be down, for instance, at any time. And that's very important, because the second thing that we truly recommend is to add SLO and SLA information about the service, right? So what kind of uptime can I expect from this service? Because I need to promise some kind of a uptime to my clients. So that's very interesting if we build distributed systems that connect different services. Very important is to understand upstream and downstream dependencies, right? So if I'm going to be responsible for a given service, what is, who do I talk to? Who I talk to? Which teams do I depend on?
And who talks to me as well? So if if I'm going to have a downtime, or if I want to take the service out, who is going to be affected?
And any other information
Anything
which we
that's
can
relevant.
discuss. Yeah, I'm going to show you a different tool called Revolt Tower. So this is an in-house solution for doing exactly the same. It's really well integrated with our stack, so I can see the team, people, Slack handles of the team, of the people, CI/CD, metrics, infrastructure details, and so on and so forth. So this is how it looks like from the inside. You can see, for instance, a number of business services. On the right, we have a full description, materiality, so I know what to expect. The team with the link and all of the links included.
CI/CD.
CI/CD, we'll come back to that. Yeah, definitely. And for instance, dependencies, right? So I can see that there are different services that are dependent on. You can see one of the services being in orange. It means it's going to be deprecated, right? So I know that I'm actually dependent on one of the services that its lifetime is coming to the end. So that's something we have out of the box. There are service maps on the, you can see on the left. So for instance, I can see the whole map of all of the dependencies and so on and so forth. Happy to discuss that tool. Coming back to this picture, if you have another look at this system, what do you see? We definitely, when we discussed, we saw a different problem as well.
You look at this, it's complex. And yes, complex means there is going to be complexity in the system. And if you add technical complexity onto a complex problem, you get something that is going to be not only very complex, but it's also probably going to be very complicated because we're humans. How do we tackle that?
So definitely one of the concepts that we want to apply when thinking about such systems is systems thinking. So we had a number of conversations also with Jarek here about systems thinking. So it's another person to talk to about that. But there are two things to remember about systems thinking about when you think about system. As Andrzej said, if you add more and more technical components to a system, what happens is actually you increase something in the systems, right? And in the systems thinking, it's called randomness. By introducing the number of things between the silicon and your API endpoint, you're really introducing a number of variables that make your system potentially unstable. The more there is, the more unstable it can become. Why? Versions of languages, versions of frameworks, versions of operating systems, and so on and so forth. So that is something you can control. Your responsibility is, of course, to limit the randomness.
Because apart from randomness, there is also the complexity, which is, if we're building a system, it tries to deal with a more complex business reality, tries to have more services. It will be more complex. That's just the nature of things. So complexity, the number of relationships, interactions, and computations required to change system state, which means, hey, if it's a complex, if it's a system that is complex, can do a lot of things, being able to do those things means complexity. Yeah, that's part of being able to do more. It's more complex.
There are a number of materials on the systems thinking, and we definitely encourage you, if you want to go deeper, if you want to become a better engineer, definitely get into that topic. So we wanted to use the Weinberg model. So Weinberg model talks about three types of the system if you lay down randomness and complexity. So as we say, randomness is something we invite to our systems, complexity is natural, right? So to give you an example, if I'm collecting the data about my users, the complexity is low. But if I'm calculating, for instance, different tax models or, I'm not sure, different tax reports, the complexity is naturally very high, especially if I take into consideration that, for instance, a company works across a number of jurisdictions, right? So that's your x-axis. The y-axis is randomness. So something we introduce by a number of moving parts in our systems. And you will have naturally three different types of the systems.
So the first is organized simplicity. Low randomness, which means, for example, low number of stacks. We've limited the amount of things that move, and low complexity. So the system is simple. Everything is well understood. A simple system. An early system, maybe.
A simple CRUD system, for instance.
There exists engineering platforms and tooling to solve common problems because it's easy. Doing CI/CD, good example. It's a solved problem almost.
Unorganized complexity is something that we have a very high randomness, and whatever, at some point, these systems become very random and we cannot really trust them. So things go wrong very quickly. You can recognize them in your production environments by the fact that they, for instance, are by nature very unstable.
Anything that's dealing with reality, anything that's basically the product, is probably falling into that category.
And the third one is organized complexity.
And that's the system that can deal with the business reality. That's medium randomness, medium complexity. So we've conquered some of the previous elements, and we came up with something that solves it using simple approaches. And that brings us back to that picture. The bigger the complication, the bigger the randomness, the more messy this picture would become.
So I wanted you to think about your systems, right? So you have a number of services, hundreds of them. Imagine the situation where you unify the stack and unify the tools across all of the services. The randomness is quite low. I mean, manageable, right? But what do? What happens if you do the reverse, right? You say, we're agile. Every team can have their own stack. They can have their own CI/CD. They can have their own databases and so on and so forth. Now, imagine what happens then, right?
Well, the thing that we want to avoid, and the thing that happens if you have that complexity, is basically you slow down. And then how do we do that? As Wojtek just said, sources of randomness, frameworks and tools, as in somebody uses A, somebody uses B. I will not mention any queues or distributed databases.
Frameworks.
But if there is a person who loves one and hates the other, and then you have 3 different people and they all have divergent preferences, and you all have multiple ways of solving that, then that's just unnecessary sometimes. So in the context of organizations that try to deliver quickly and reliably and efficiently and well, choosing your own technologies everywhere by everybody is an anti-pattern. Organizations that we've seen that are successful and remain successful usually limit themselves in that scope. That's probably going to be use the JVM, use Java, use maybe Postgres, use maybe something that talks SQL rather than introducing a layer of translation, and so on and so on.
The second thing is differences in processes. If you think about that, the technical side is one thing. Second is how different we are in the releasing the software, right? Software development lifecycle and maintaining it. Let's say we create one company. Imagine that if we have different processes and every part of the room has their own processes, how easy it is for us to say we know exactly how to maintain the product, right? And what is the chance that things will go wrong? So a software development lifecycle differences is definitely something that really introduces the randomness in the processes.
And also, if I decide to use whatever Wojtek is using, I can piggyback on his experience. We have a template that we can just copy over. I don't have to reinvent it. If it's not essential to the problem, to the business reality that I'm trying to conquer, hey, I won, I saved time, and so on and so on. And this, at scale, scales even more.
And differences in skills and knowledge and understanding. That's the third thing. If you have a company, and think about how in your team, how big is the gap between the most experienced person, the most knowledgeable person, and then the person that knows probably the least, right? If the gap is big, there is definitely a massive randomness introduces because you will do things differently. So one of the other things is, of course, we need to focus on that. Because in the end, our responsibility is not to focus on the technical stuff, right? So that should be easy. If you want to grow fast, you really need to make sure that you're producing the value fast. And that's our responsibility. And I wanted to give you a very quick introduction to how Revolut, for instance, does it. So a simplified architecture. So what you will learn is it's super simplistic by design. It's very, very simple. And it's one of the constraints. So this is a type of the architecture patterns that we're using. And you have, of course, the choice. But we're limiting the choice by design to a number of approaches. Simplicity standards. So we enforce these constraints. When it comes to the software development lifecycle, when it comes to design, and it's also enforced by the tooling. So, for instance, the tower that you've seen will enforce a number of things because it knows, for instance, it's a Java service. And the short feedback loop, so that's very important. So what is the service topology and what are the different types of services? It's very, very simple. So these are logical services, so they don't need to be a separate deployment units. Of course, on the top you will have a front end. Then you will have the front end API, so basically speaking definitions of our API endpoints. Then you will have flow services, so something that glues domains model together. Then there will be state services, so domain services, in other words, and they will keep our models and entities and will ensure, for instance, the persistence, publishing events, and so on and so forth. And there is an extra type of the service that is a gateway service, right? So one that really separates one infrastructure for another. In the reality, it looks very, very simple. So from our cloud provider, we have network and security, of course. Then we have exactly what I described, plus event store and event stream, and VMs, Kubernetes, object storage, and observability straight from from our cloud provider. And if you think about that, that's super simplistic by design. Like literally in Revolut, every service, for instance, every Java service would be deployed service in Kubernetes with our own internal framework that supports some DDD concepts. And it will use Postgres as operational database, but also as event bus and event store. And that's it. Nothing else. It's super simple by design. Hundreds of services. And here, I really wanted to come back to this slide, so you will see that, for instance, the side that you see on the right, it means that actually underneath, there is a whole pipeline on CI/CD that will take care for me about configuration of the service, hooking up the whole monitoring, so observability governance. It will create everything that I need, etc., etc. So I don't need to think about anything. It's created for me automatically. If you do this this way, so everything is configured and automated, we also can have things like, for instance, you probably know tools like Can I Deploy, right? But it's even better because you can think of different aspects of services, of their life cycle, of their responsibilities, including costs, including, for instance, the different requirements, functional and non-functional, that we can have, and you can test that. And you can put it in the dashboard for the team, and every team can see, okay, how am I doing, right? Or you can introduce new standards and do the same. Okay, with that.
We know that technology is a source of simplicity. Okay, then we know that, we've done that. What do we do? What do we do further? How can we actually execute well? How do we know that we're executing well? Or differently, how do we know that we're not?
So there is the second pain session. Time for you to feel some pain. Okay, we will give you some examples of things that we saw that will go wrong and are really good, as we call it, heuristic of pain, that you have a heuristic of trouble, that you know that you're in trouble, right? And we start with this one.
Why do they commit to our code base? Somebody somewhere said it. And if you've heard that in your place, or if you've said it yourself, then that's a sign of blurred boundaries. So there is no clear ownership. And people might have then conflicting architecture drivers. People might have different assumptions. Somebody might have the attitude of, I don't care. And they will do, quoting, do whatever, end quote. And that means that it's all going to be a bit rotting and messing and so on. And we don't want that, obviously. We want to be in a fun organization that keeps making good software quickly, reliably, and so on. So...
Okay, second one.
More signs of problems.
When was the last time you've heard it's them?
This incident is not ours.
Or they added it, let them fix it, right?
If you remember the Western categorization, this is our ownership, this is not our problem. Hey, the same company. So generative plays, it's our problem, always.
And we see that as a lack of ownership. That's a big problem, right? So shift the blame environment. So you throw the ball to somebody else's code. Fear, that produces the fear of innovation. That results in low morale and higher turnover. And we wanted to remind you, very rarely, deployables, modules, and teams are equally the same, right? So we need to understand very well what do we own, who do we rely on, and who do we need to help. Another one. When did you say or hear something like, let me fix it?
Do you have a person in the company that always fixes the bugs, that has a superpower because they know all the system? And if you do, that's called a hero. And a hero, as in short term, they might look awesome, but at the same time, they come with problems. They create knowledge silos because they know, and you don't. They learn, and the teams that have made the decisions that led to a problem don't. They reduce shared ownership because I don't see the impact of my changes, and that means, I think, in my perspective, on my own, or they are the person who is always going to be very grumpy and unhappy, which means they might risk a burnout. They might leave one day, and then what happens? Well, you run on momentum, and what?
You can have more than one hero, right? When was the last time you've heard, contact them? It's them who do it.
Sometimes it might be a platform team, sometimes it might be something central, an infrastructure team, and they come under different names. A team that is going to mandate and throw decisions onto other people without knowing their consequences. They will use their own perspective, because that's what they have, which means their perspective is not going to include perspective of the things that they reach. And that's normal. They will have somewhat reduced accountability because they have to make a solution that works across the board, and that's an argument that nobody's going to discuss. They will have a bit of a lack of diversity in problem solving because they are a bunch of people with a hammer, with a specific perspective, and their perspective is, we want to roll out something that works across the company, which means across the company is the primary constraint. They don't understand the specific drivers of specific domains. And they might be a potential for bottleneck. Because if they are the central, and you have to go through the central, then, well, you've been to a central train station. You know what can happen there, and if a hub is delayed, everybody gets delayed.
When was the last time when you had a problem, you've heard, create a ticket, we'll take care of it, right? So it's another problem. And when you think about it deeply, it might be the really good sign of siloed teams and conflicting priorities. So let's say, as we discussed, you know which teams do you depend on, you find a bug in their API, or you want the change, and you hear exactly what I said. That's a good problem or in conflicting priorities, for instance, which lead to missed opportunities, very often duplication of efforts, because how often did you react? Oh, if it's going to take you 6 months, we're going to build our own. Then how many invoicing systems have you got in the company, right?
And just to be clear, we're not against creating tickets per se, because sometimes you want to record somewhere that you've done something, especially if you work in finance or any other regulated area. You have to have that, because there was a reason that there are some nodes attached to a common place about an interaction that you're having between teams. But if there is an interaction and doing the ticket is part of that, that's fine. But if you have to write a ticket and then maybe they will come back to you.
We're entering bureaucracy, right?
Oh, you named it.
Yeah. Another one. You have a business request, right? Business feature request, but you cannot deliver on time because database, even something, technology or framework doesn't allow you to do it, and you need to build a workaround. That's a good sign that technology becomes a constraint, right? So you probably chose the technology prematurely, or you're too bound to the technology, or maybe your business problems are not fun. And one thing that is true about all of us, we want fun. And if we don't have fun in the problems that we solve, we'll introduce fun anyway. So it's also called CV-driven development, right? And to end this up, we all seen this problem, at least as we discussed with Andrzej. This is something we all witness in different organizations. Okay, so what are the practical tips from our perspective and how we turn the wheel around and actually make it a better environment?
Or if during the past few slides you said yes to most of them, and then, well, one option, of course, is to run away. But if you want to stay and not run away immediately, or you have a notice period to serve, there are some things that you can at least try doing to make the world a better place. Of course, you risk becoming a manager, but
first and foremost, make sure that the boundaries are clear. So it's not obvious, but let's make sure that our responsibilities are absolutely clear. A very good sign to we're going to touch on that, but there are some very good signs that boundaries are not clear. If you cannot assign the bug, or you have an incident and you don't know who's owning it, it's a very good sign you have work to do, and let's make sure that everyone is aligned.
And you do that by, or as you go along, you will try to make explicit absolutely everything. So implicit, I know, you know, I know that you know that I know. But if you all join
or I don't know that you don't know, by the way.
Also, if you put it in writing in a central place that becomes the source of truth, this is the source of truth. This is why Backstage, or the wiki page if you need to start, or you're a small organization, making it written down in a common place, and that is how we operate. This is where we derive our source of truth from. And I make a change to the wiki. I say I'm not responsible for that because I do something else. Then do we have a gap, or do we have something else? At least everybody's on the same page. We start from the same page. It's easier to reason. And that sadly hits a bit of a clash.
We wanted to recommend you one thing when you have such problems, which we called continuous ownership refactoring. So basically speaking, make it a habit. Whenever you have a problem that I mentioned, right? So PR reviews confusion, how to assign bugs, or incidents with unclear ownership, and you have the question, who should own the thing?
Just as the organizations that you work in might do reorgs at the top stage, the same you can do to services, and the same should happen to services. As in, who owns a service shouldn't be because it's historic, it should be reflecting reality, or who is the best person to support it, and follow that.
Yeah, make sure that you write it down, make sure that you improve. For instance, the service discoverability tooling and so on and so forth, your playbooks, whatever. That really will help people to get the knowledge more explicit.
It also sets the culture straight, because it makes it, this is what we follow, this is what we claim to follow, and this is what we actually, that translates.
There are a number of techniques that we found that are working really well for rethinking. So whenever you have such a problem, there are a couple of steps that we recommend to take. First is having a clear domain ownership, right? So we agree it's owned by us because it's close to whatever we own, or maybe it's exactly what we own. Second is proximity to the issue, right? So we own this, it's kind of connected. Let us take the ownership of it.
It hurts me, it hurts our team. We will fix it because we don't want that.
Exactly. The third one would be role-based ownership, right? So especially for the platforms. So we are the team that does X. That's X something. Let's make sure that we own it. And if you really cannot agree, ownership rotation sounds like a good plan.
It's a
it
starting
also
point.
Helps everyone to learn.
It also gives people the perspective, and if it's a huge burden, it limits the burden because some people don't enjoy it for a long time.
The best way to learn about your organization and the things that work well and don't work, from my perspective, are incidents. And we underestimate the incidents. And we underestimate especially the postmortems. So I would encourage you, if you don't have a really good culture of postmortem, that's one first thing that you should improve. It's an amazing way to learn about it.
Just a quick question. Is anybody unfamiliar with what postmortems are? I see no hands in the air. Okay, I see some hands in the air. I see one trolling hand in the air. I appreciate that. If there is an incident, you write down a story about what happened. How do you do that? Well, here comes an answer.
Couple of quickly, because we don't want to dwell too much details. I think that the things that work well for us, let's make sure that the template is known and it's used by everyone, ideally, right?
What happened? What was the impact? So how many users? What was the monetary damage, if any? What are the queries or logs or monitoring links to find that? How did you reach that data so that when somebody actually tries to follow that, they can go there? Screenshots are awesome. How was it detected? What was the response? What was the timeline? The timeline includes how did it happen, what happened, and when was it resolved, what were the actions taken. It's probably going to take 2 weeks into account, maybe less, maybe more, depends. What was the root cause? How did you get there? And 5 whys, how far should 5 whys go?
Exactly. Agree with the team on the rules. So from my perspective, make sure and take care of the culture where their postmortems are blameless. So if you've seen the previous picture, there is nothing about who to blame, right? They need to be accurate. Make sure they're actionable, and I would add that actions are trackable, so that you can understand, because it's great, oh yeah, we do postmortem, and half a year later we have exactly the same incident because nobody really did anything about it. And they're rapidly created, right?
And they have to be rapid, because you will forget. Whoever was involved in the incident might be involved in another incident, or the details will leak. And you will forget about them, and that's natural.
Couple of tips. So all incidents, we also do postmortems for, we call it near incidents. So we almost got hit. We dodge the bullet by millimeters. We keep them trackable, as I mentioned. We definitely drill into the root causes and lessons learned. And one thing that we also do is we challenge each other. I will come back to that because that's interesting.
And one another thing, postmortems should be open. If there is somebody who claims that postmortems represent secret knowledge and people shouldn't look at them, no. For engineers, this should be in the open. This is how we learn. This is how you learn. This is when you join a company, you can see, okay, what are the issues? Where is production at? How do people tick? How do people respond? What are the people involved? Because all of that are going to be written down in those stories, if they exist.
If you want to make sure that people do them, by the way, the last item, celebrate improvements, is interesting. So you can create like a dashboard, for instance, with the number of action items addressed, implemented, and celebrate the improvements in whatever you do, the way to celebrate the improvements, right? Another thing, so we know where to look for items. We had all of these incidents. We learned is actually another recommendation working with the bigger systems at scale that scale fast is caring about your external and internal dependencies.
Which means introducing dependency hygiene. Who are they? What SLOs and SLAs do they follow? SLOs versus SLAs, SLO is the appetite for quality, SLA is what's in the contract. Who are they? So that you know which teams to follow, who to track. If you know who to track, well, you will probably look at the revolution from time to time just to know what they have on their mind. If they tell you that they are going to sunset their service and it's not going to be no longer, you would like to know what the replacement is. And if
you want to get involved and probably, also maybe adjust the date of the retirement, right?
Or if you're a team that maintains a service that has a ton of dependencies and you want to announce it to everybody that you're going to shut it down end of the quarter and you will have 2 weeks everybody to migrate out of it, that might be a bit unrealistic. And if you know about that, at least you will know.
Well, the one thing that we recommend is if you have tools like we discussed, right? Discoverability tools that help you to understand exactly who do you depend on and why and what. We encourage you to get really involved. Ideally, teams should do some kind of RFCs, system design documents, and my personal recommendation is get involved. And getting involved, especially in the way, what works really, really well is sparring sessions. So make sure that, basically speaking, whenever there is a system design or RFC review session, join this session for the services that you depend on, and make sure that you're trying to find all of the problems all together.
An RFC, obviously, a design doc is going to live somewhere open, so have a look at them. Maybe if there is a team that you're interested in, have a look at what they do. Also visit something that you don't know anything about to learn about how other people do that, because you will see what questions do they ask. Maybe they approach a specific problem in an interesting way, or maybe read some of the past design. And if you're doing RFCs, you're going to reach one problem, and the problem is,
who do I inform about my decisions, right? So, okay, I have a map of dependencies. I probably, if I change my API contracts, I know who to inform. But am I sure that everyone is informed? Because maybe, for instance, I'm based on the technology and I need to make sure that somebody else is also consulted. Or, for instance, I work in the bank and I need to make sure that, for instance, security AppSec team is also looking into some of the changes, right?
Do I need a blessing from somebody?
Do I need a blessing, for instance, right?
Or if it compiles, ship it. Well, there are different ways of doing that. One model that we have used with success in the past is called RACI. RACI stands for this. Responsible, who needs to make sure that the change or something happens, who is accountable. So
whose head is on the table,
yeah,
right?
Whose head will roll, who needs to be consulted. Good example is probably, do you need to consult the security team? Probably. And who is informed? Other developers who use your service.
Maybe other departments, for instance.
And so on. We're not saying that you should describe every single process in a painstaking detail. Just like when you're doing Agile, you probably don't want to do safe. But know the general groups that you have in the organization, and you get a feel of, okay, this is this kind of service, so I need to speak to that and that, inform them, and this is how you inform. And then you have a model. And when you have a model, it becomes a template. And the benefits are?
It enhances collaboration communication, so it's clear, definitely. It improves decision making, because when you make a decision, you know who to make it with, and you know how to inform everyone. It definitely facilitates the roles and the responsibilities in the team. And I would say review regularly again, and improve whenever you do it. So to give you an example, for instance, responsible would be a team owning a feature. Accountable, that could be me, for instance. Consulted other departments, or for instance, the CTO or AppSec team, and informed the whole department, for instance.
And one thing that's invisible here, this also helps you limit the number of people that you invite to meetings. Because if somebody will be informed, well, if they want to, of course they can come to the design reviews, but they are not a mandatory member of the meeting. They are not an optional. You don't need to tell them, hey, we're going to go through that. You don't need to wait for them and synchronize and so on. And it becomes a much simpler process.
Okay, so you build a system, you deployed it. It's no longer a greenfield. It's actually changed the color a bit. So how do you know that you need to refactor it? And what means can you use to refactor the architecture? So we wanted to give you a third session of pain.
That's the last one.
That's the last one. So let's quickly go through that. The first one. When do you have a good signal to rebuild, rethink the architecture?
It takes forever to build. As in, if it's an hour, then it's definitely too long. I use 10 minutes as a rule of thumb. Hours, not minutes. Yeah, fear of releasing is what happens immediately after, because, hey, this is going to take so much time, which means because it takes so much time to build, we are going to pretend to test more. High percentage of red builds, because we don't get signal often enough, so the change sets become bigger, and then it goes, well, it goes.
When it's a Sunday, and you're tired already, and you start to sing this song, that's probably another good heuristic of pain, that you work on a system that is hard to maintain. Which means that everything that you do is hard, right? The changes are hard, steep learning curve, there is lots of repeated code, and so on and so forth. We can continue.
Or maybe you have 17 layer of abstraction.
Exactly. If you have a release train to catch, my God, or you have a person who is called delivery manager, that's probably another good sign that you have a very slow time to production. And there's time to rethink the architecture a bit. So, for instance, the good heuristic would be that there is a forced synchronization of changes, infrequent releases, and all the problems that come with that.
CI/CD to the rescue, or if you don't do CI/CD and you miss a synchronization window, well, you get to hit the next one, which means everything becomes slower and slower and slower.
Another good signal that you need to rethink your architecture is if Black Friday comes and you're not afraid, if CTO is not going to ask some difficult questions after it, right? So it's a very good sign that your architecture has performance issues, right? So slow response time, frequent crashes, or some bottlenecks that you can find. Okay, and think about scaling the architecture. And we promise it's a very quick one that we're going to touch on. Okay, so you had signals about problems that you have. Now, imagine that it's a big system, right? If you're lucky to work in a successful company, usually that will be a large system to take care of. How to refactor such an existing system? Of course, quitting is not an option, let's say. How we wanted to introduce you to the theory of constraints. So ideally, think about one thing that is your biggest bottleneck. One thing. Or stack them.
List the problems and say how much they hurt or which one hurts the most.
Exactly. So examples are, to give you a number, which we probably discussed during the heuristic of pain session, this could be your top number one. And focus on only one of those. Don't say, okay, we're going to refactor the system. This time it's going to be beautiful.
Or do a complete rewrite. That never works. You pick one, and then you focus on it, which, formally speaking...
Well, you exploit it, meaning that you work on it, you fix the problem, you continuously focusing only on that while refactoring the system. You remove the constraint, and you identify the next one. That's the theory of constraint in practice. That's basically speaking one of the DevOps fundamental concepts.
If you've done software optimization, you might see some similarity with software optimization, but one thing that I have to mention is you identify the new constraint by doing a new set of constraints, because when you've removed the top one, what was behind in that list might be reshuffled. You probably will have some new members of that list, and some of them will no longer be a thing because they will be taken out by surprise.
Another concept that works really well, it's this one is coming from the perspective of what's the biggest bottleneck. Another one, if you know what you want to improve, and it's not necessarily your bottleneck, right? But the fitness function. So you start optimizing the system to make sure that you have a certain metric improve over time. So we recommend actually getting to know both systems. There are tons of really good materials on the topic. Combining those is perfectly possible. You can do it, and you can actually refactor the system. I wanted to give you an example. Sorry, Andrzej.
And Wojtek said something very important. Over time. Like with test coverage, there is no magic number. I know, shocking. You look at the trend over time. Same for response times, same for build times. It should not go down, or it should not go into longer, depending on which one we're talking. Over time, and the trends are signal.
The project that I was working on, and I can happily say it's finished, it was actually when I joined the company, Revolut Business was one monolithic system. Imagine a system that has 3,000 endpoints, 3,200 exactly, over 450 consumers, and it's a monolith. So it was painful. Let me put it this way. So, 2,100 endpoints and 500 consumers. Nearly 20 teams contributed to this monolith. So it of course was painful for another reasons as well. And the biggest constraint, as we agreed, what was the biggest problem that we've seen was the build time was over an hour. So the feedback loop was really long when you were working with the system. And mean time to production was actually much more than we wanted. And we wanted the mean time to production for our services to be more like an hour. So this is exactly what we did. We focused on one single constraint, mean time to production. We wanted this to drive our decisions. So when we were working on modularization of this monolith, this is what we actually focused on, making sure that every team can very quickly, much quicker, so between 10 and 20 minutes at the moment, and we're going still to improve it, deploy the changes to the production. So this is we've done this with over 20 teams. If you want to talk about architecture refactoring on such a scale, happy to have a chat with you. Okay, with that, we're finished. No more pain sessions, and there are a couple of takeovers we want you to take.
So the cold shower takeaways, which mean we're coming to an end. The bad system will beat a good person every time, which means if the system is rigged against you, you might be the most driven person in the world. It's unlikely you're going to win, which means the way to help an org work well is to build and continuously refactor a system so that it enables and helps people achieve the correct results. That's why I say if you're starting to deal with that, you might risk becoming a manager. It's not that bad, but...
One thing that when I'm thinking about working with organizations that are really fast and fast performing is they're ruthless sometimes. They're known to engineers as strict organizations. They're really intensive, let's say. And one thing that is interesting is actually I realized it's learning from the nature. You don't get really good if you're not exercising hard, right? So if you want to be really good at something, really performing well, apply stress to your team, to your service, to your processes. Make sure that they bend. Make sure to understand when they break. And these are the points that you need to improve. And this is actually, from my perspective, really the one thing that differentiates the teams that are really good from high performing from others.
Another important thing is shorten the cycle time, because that means you can iterate quickly. And if an iteration is failed, another one will come soon. If there is a failed build, you don't have to wait for a long time for the next one. If it's a failed release, the next one is a short while away, which means it's not generating fear. And we have small increments of knowledge, and that's something that actually gives us very straightforward signal. Is it a bad change? Is it a good change? If
And
it's
you said something important, right? This is not only short cycle time, it's not only about our CI/CD, it's about the knowledge in the organization. Make sure that you can learn quickly, and you shorten actually this loop, right? Make sure that things are explicit. So that's something we really want you to focus on.
And this mentions organization growth mindset. So the assumption that things will evolve over time, which aligns very nicely with the generative organizations from the Western model and directly clashes with bureaucratic, everything is set, this is the way we do things and there are no changes attitude. And yes, that's accurate. We focus on those generative cases. The goal is to design a system that's going to help people do things which
Quicker.
You want to encourage people. You want to, if somebody has energy, can we tell them where to channel it? Yes, awesome. Can we help people make decisions in pairs? Awesome.
And make sure that you focus. So at any if you want to grow fast, you need to maintain focus. So remove as much of the moving parts as possible, right? Learn from your incidents what doesn't work. Make sure that you understand very well. Focus on fixing those. When you refactor, when you do the big refactoring, don't do the greenfield, beautiful, kumbaya refactoring. It's actually make sure that you focus on the right thing, challenge yourself with this thing and deliver it and remove anything that is non-essential.
And with that, we will say, that's the moment for your phones. If you want the slides, we're very happy to share. Drop us an email. One thing that we will ask, you have to write us some feedback, but we'll be more than happy to share the slides. And I think we have to show the next one. The next one is Slido.
About questions, right?
4 questions. Do we have any questions in there? Maybe. So, do you believe that shared responsibilities are leading to more efficiency? My opinion, no one is exact responsible, then no one cares as well. Yes and no. So yes, they have to be shared, but there have to be boundaries. I would say teams are the unit of responsibility, so a team is going to be responsible, and within a team, the lead is going to be accountable. So if something is wrong with the team, the first person to have the conversation within the team is going to be the lead, and they are the ones, they do not have to do the work. They are responsible to make sure that the work does happen.
Next question. Don't you think that standardization of the stack technologies blocks innovation? Don't you think that standardization of the stack and technologies block innovation? We can add processes to that, right? Very good question. If your innovation is technology, probably don't limit your stack. If your innovation is product, a business product, for instance, I would say the more constraints, the quicker you are, the more innovation you have, because your innovation is not in the technology stack, is actually in the features. Yes, of course, sometimes it's time to rethink the technology stack because it may limit you, but don't drive it don't let that become your driver, right? The technology stack.
And also, I don't know of organizations that have reached commercial success because of a very specific technology, unless they were a technology vendor. If you're in a business organization, technology is a tool to get somewhere. Changing a live version of the library is not going to guarantee the success or failure, usually.
Oh my God, how many questions. Sometimes ownership is not the problem, but understanding, knowledge about application by customers. What customers should know about application in case of error? I would say it's that's a very good question. You should think as the user. My lesson from different companies that I worked with, don't show technical errors. Put yourself in the shoes of the user and think what they should see on the screen to feel comfortable. If I'm the user of the bank, the last thing I need to see, something went wrong in the UI, right? I don't think that I would trust such a bank very much.
And is code ownership, and that's going to be the very last question, everything else, corridor, more than happy to talk. Is code ownership, in your case, the opposite of collective code ownership? The code ownership is collective, but there is a specific team that has the context, and they are the ones that think about, does this change fit where we're taking this service or this area of the code? That doesn't have to be a single team. It can be a domain, an area. It depends. So no, it's not opposing. It's if you have no context about the area of the code, don't push and merge. Ask somebody with context for feedback. Maybe pair, maybe do code review. Talk about the design if you're proposing a different one, because there might be things that you don't know, and don't break their existence. If you're making something that you're absolutely certain, absolutely do it.
Maybe last one, because I like it.
Sure, shoot.
Regarding service discoverability, how to maintain up-to-date data in such tooling, like the Spotify? Should we trust BAs to make it manually or by some call? There is one way that works really great. Integrate it with your CI/CD pipeline. Automate processes based on your service discoverability platform. This way, to introduce any change, I will have to update the service discoverability tooling, right? So there is no way they are out of sync. The more you automate such things, the clearer the knowledge will be.
If you drive commit rights from that, people have to be correctly attached to teams. If you drive database access through the network limits, it has to be correctly expressed, otherwise the service cannot work. It's as magical and as simple. It takes time to get there, but it should be developers if it's something that developers own. And if BAs are usually using CI, well, source code editors in your org, and they are happy doing YAML, I don't see a problem them editing descriptions, but it might be a PR because if it's malformed, it will be unhappy. And with that, we will have to say thank you very much. It was a pleasure. Please vote in Slido, give us feedback over email, talk to us in the corridors. We'll be around. It was a pleasure. See ya.